Hello guys, my name is Max. Welcome to this video today. We're going to program a simple Asteroid game using JavaScript and HTML as usual. Before we get started though, I just want to go through some basic algorithms and linear algebra that we're going to need in order to program this game effectively. So the original Asteroid game used a vector monitor for its graphics, so it offers some great advantages like good resolution at a cheap price and development cost, and yeah, so that could draw sharp graphics and to stuff like that. But also has some limitations, like it couldn't draw filled shapes, and it could only draw the outline of shapes. So that's why the asteroids here are drawn like this, with just stroke graphics and are not filled. So a polygon is a geometric object with a finite chain of straight line segments, or that are called its edges or its sides. And each point where two edges meet are a vertex, and in plural that is vertices. So here's some different polygons. So we have convex polygons and we have concave polygons. Concave polygons are basically just have these kinds of shapes within them, and that makes stuff like collision detection a bit harder than when dealing only with convex polygons, like a triangle and a rectangle. So in code, you can implement the polygon something like this. So you have an ordinary list of values. So where each two elements makes out a vertex or a coordinate for a particular vertex, and then you can just loop through all the points, and then you check if it's the first point, then you move to that point, else you want to draw a line between them. And you can use that using the canvas rendering context, begin path, and stroke methods. And so yeah, that's basically it for how to draw them. So here's an example what it can look like, and here I have the code for it. So you can see that I have just declared a list of points, and then I draw them to the canvas using this begin path and stroke methods here, loop through all the points and stuff like that. So one quite important thing to do, at least when developing a game, like as we to check if a particular point is inside of a polygon. And to do that, I looked through the internet and I found out, and I found this blog post or article where a guy, Randolph Franklin or something like that, checks or describes an algorithm you can use in order to test if a particular point is inside of a polygon. But it is written in C, and I think the original code was written in BASIC or something like that, and we won't bother going into that. But so I basically just read through the article, and I found out this sort of what the algorithm was about, and I wrote down this pseudocode here. So basically what he does is he loops through all the points in a list of vertices, and then he checks if the y value on the test point is between the y point and the previous y point in the y points of the vertices, of course. Then he checks if the x, I think it has something to do with the projection of the difference in the x of the line on the x-axis. And then he switches a boolean from inside to outside each time he crosses the line, or from outside to inside. He toggle it between the different states. And that's basically the contain points method. So here it is in JavaScript code, and that I have written, and that's the basic code we're going to use later on in the tutorials. Probably not until the second part of these tutorial series though. So I've implemented this in this live demo here, and you can see when I hover over the polygon shape at the edge, that the edge or outline turns red. Another useful thing to be able to do is to rotate the polygon, and you can do that by a regular rotation matrix if you see each of the vertex as a vector originating from the center of the polygon. And you can rotate it around that center, or arbitrary points that you take the originating from, using our rotation matrix. And a rotation matrix is basically, in 2 dimension at least, is a 2x2 matrix that you just multiply by 1 by 2 matrix. a 2x1 matrix. And the algorithm is as follows. So basically it take each row here times each column here in the second matrix. And the important thing here is that they are compatible. That means that the first matrix has the same number of columns as the second matrix has the number of rows. And you take stuff like here, you take x times a plus y times b, and that will make out the new point in the or the new row element in the vector, and the dimension of the second matrix is the same as the result you will get here. And then you do the same here for the second element. You take x times c plus y times d, and that will give us you the second element in the result vector, in the results. Anyways, so rotation matrix, you can do that by some linear algebra, some linear transformations. So I did that before I did this video, and I found this clockwise rotation matrix in the HTML canvas Cartesian coordinate system. And that's just basically cosinus with the angle you want to rotate with as the first element, and then minus sinus, cosinus of that angle you want to rotate with as the rest of the elements in this order, in this fashion here. So in code, again, it can look something like this. You create a matrix, then you take out the current x and y values. You look through all the points or all the vertex in the vertices array, and then you take out x and y points, and then you change them to these new values here, depending on the same as we did here, according to this algorithm here. But it's a bit redundant, as you can perhaps guess, since you're doing the same computation here twice, both for the cosinus and both for the sines here. So instead we can take out the cosinus and sinus, and we just take minus sinus here instead of taking plus this element here. We can take minus sinus like that. So that's a more efficient way of doing this. And if I just uncomment this line here, reload the demo page, you can see now that the polygon is rotating, and it's still working when I hover over it, that the outline turns red. So that's basic knowledge we're going to need to have in order to program a game. So let's get started then. Before we get started though, I just want you to go to Google and search for John Resig class. I don't know how to pronounce his names, and anyway, you can go to this, search for Google for this, and it should be the first link. And you can read through this blog post, and where he basically described a simple class system, or class inheritance system you can use in JavaScript that he have developed. And it's really smart, and it's really good. I like it a lot. And it also have this super functionality that you can call methods on the superclass, in this case the person class, and passing arguments to that super method and stuff like that. So anyway, you can read through the blog post if you want. Link will be down in the description. But the important thing is to copy the source of this here. So just go down to the second section of the blog post, copy this code here, like that for now. So let's get started coding. So I'll just create a new folder called Asteroids, and let's open it up with Sublime Text now. Let's just close down this test page, and let's create that file we just copied. So I create a JS folder, a lib folder, and then I'll call it class.js. Inside of here I just copy this code from the blog post, like that. And then we'll have our main class, our main file, main.js, and canvas.js for now, I guess. And that was a bit strange. That should be inside of that, I think. Well, let's see. Yeah, the main here was wrong. Let's move it. So that, guys, and it should of course be in the JS, like that. Yeah. Then we'll have an index.html5 as well. And why not use a CSS file, since I haven't used that in any previous tutorial. So let's create a CSS folder and a style.css file in that folder. So let's grab some basic HTML, set the title, Asteroids, like that, import the CSS file, CSS, style.css, and all the script file we have created so far. So I have the source, JS lib class.js, then we have the source canvas, JS canvas JS, like that, and we have this the main file as well, so JS main.js. And in the body, let's just create a script tag, and inside of here, let's just say game equals new game and game.run, like that. So let's go down into the main class or main file, create that game class. So say game equals class.extend, and that's the syntax from the blog post. And in the constructor, I will leave that empty for now, but in the run method, we'll just log out the message to the console for now, so say console log test. Now for now, if you open this up in a browser, look in console, we should see the message test written out for us. So yeah, that's awesome, it's working. So far so good. So yeah, let's create our canvas class then. So you say, well, canvas equals class, put extend like so, and then the constructor, it'll take a width and a height like that. A height, I said, so bad at spelling. Anyway, and then inside of here we create initial canvas or a member called canvas. That's basically equal to document.create element canvas, like so. And then we set the width of canvas to the width parameter, and we set the height to the height parameter. Then we grab a context, and now we use this self-invoking function here with the context parameter that it later will return. That's so we can add additional methods on the context. I will explain later how we will do this. But anyway, so the argument to this self-invoking function will just basically this.canvas.get context 2D. So we'll get our to the context canvas to the context as a parameter, and it will return it for now. So this for now is the same as if we have written this.canvas.get context 2D, but we will use this sort of way of writing it, since we can do stuff like ctext of width equals context of canvas or width and stuff like that, so we can add additional members on the canvas. And let's actually add the width and the height for now. Yeah. And then let's just append the canvas to the document, to the body of the document. So document body append child this.canvas. Like that. So let's see if it works. So let's go down in the main class, and let's say this.canvas equals new canvas, and as parameters, the constructor took the width and height, so we'll take 640 pixels times 480 pixels. And let's add some styling so we actually can see it. So center canvas, the snippet I've used in many tutorials before here. Let's set color, let's set black for now, hopefully with a road page. Yeah, you can see that the canvas has been added to the page. And let's actually add some more styling, so we'll set a padding and a margin to 0 and everything. So that's good. I can get rid of the test message, and yeah, so let's code some actual stuff then. So one way, in the previous tutorials, we have created this loop function here. That basically just took the window request animation frame and stuff like that. So we'll do the same sort of concept, but we will abstract it out to the canvas class. So I will create this method here, I will call it animate, like so, and I will take a loop function as a callback, and then we'll create this wrapper, a self-invoking function, or wrapper, or whatever, around the window request animation frame. So say window request animation frame, like so, and then we say window WebKit request animation frame, or window.mos request animation frame, or window. Why not take Opera as well here? Request animation frame, or window.ms request animation frame, like that for now. You'll see that we actually work with the request side up, spell it right and stuff like that. Anyway, so we create this wrapper here, so that will return the right version, or the version that is present, and store it into this variable here. And then we create a loop variable, or a loop function that we call L for now. Inside here, we will call the parameter function here. And then we say ref L, and we have the self canvas, and where self here is a pointer towards the instance. And then we just kick off the loop here, so we say this canvas and L like so to the ref method or function, like that. So this is a bit more, we have abstracted out a part of the program, and that is something we'll do a lot in this series. We'll abstract out parts to make it easier for us to maintain the code and stuff like that. So let's go back to the main class now, and let's see if it works. So you can say this.canvas.animate, and take a function as callback, and let's log out a new message, test2, and hopefully now it should be written out test2 over and over again in console. And yeah, that seems to be the case, so it's working. So we can do one more fallback in the canvas here. So we'll create this fallback function. Take callback an element parameters, and here we say window.set time out callback 1000 over 60, like that. I guess, yeah. So that's it for all of the programs here. Yeah, so that's working. So let's start coding some actual game features then. So for this game we'll use a basic state system where we take a reference to the current state and the next state. So the current state will be null at start, and the next state it will be an ID that will store in the states object. That will be to the game at the start here, at least when we are doing our debugging. So we have the states, that's a JavaScript object, and we have the no change ID. That will set to 0, and then we have the menu state set at 1, the game state set at 2, the end state 3. And the values here, of course, complete arbitrary, but yeah, it seems logical to have them in this order anyways. So the next state here will be 2 at the start. But then here, inside of the run method, we will just make a reference here to the instance. So we say var self equals this, and then we can say if self.nextState is not equals to the states.noChange. So if we should change the state, then we will say take a switch statement of the like this self.nextState, I guess, and we have all cases. So states.menu, states.game, and we have the case states.end, like that. And then we just make sure that we set the next state here to the no change ID, like that. And inside of here, we basically say self.current state equals new state for now. That will take self as parameter, and then we break it like that. And then down here we can say self current state dot handle inputs. Why not? And we have the update method, and we have the render method. That will take self, canvas, or context as parameter, like so. So that's the basic state machine. So it will check if it should change the state, and if it should, it will change to the current state, or change the current state to a new state there. And and all of them are state for now, but later on we'll have stuff like game state, menu state, and so on and so forth. But we haven't implemented them yet, so let's just call them state for now. So let's create this state file in the JS folder. So we call it state.js. We say well state equals class.extend. So this is basically just the super class here. And the constructor will take a game as a parameter. And then say this.game equals game. And that game is basically just this self there that is pointing towards inside of this in the constructor. And then we have the handle inputs method that didn't took any arguments. And we have the update method and the render method that took our context as a parameter, like that. So hopefully now, if we just import this, we can close down the class.js. So let's import it. Yeah, let's import it here. Javascript source js state.js. Should get any errors. No, that's fine. So that means that it at least works. So let's create our game state in the JS folder as well. So I have game state.js. And that of course equals game state equals state.extend. So this superclass here is extend. And then just override the constructor now with the game here, so we can call the super constructor using this super like so. And yeah, so let's just call the update method for now. Just log out the message to see if it works. So console log test 3, I guess. Something like that. I really don't know what number we are at, but anyways. So just make sure that we import it. So there's a script source js game state.js, like that. And the main, change this to game state. And up for now, you should see that 3 written out in the console. Yeah, that seems good. So we now have a basic state system going. So let's add some content now to the game state, like asteroids and stuff like that. And let's update the context here to have like more methods, so we can actually draw our polygons and stuff like that. But anyway, we can start by creating a polygon class. So I call that polygon.js. Just import it or include it into the source file. You can include it over here, I guess. Script order doesn't really matter, but yeah. Anyway, polygon.js, like that. And then inside of here we say polygon equals class extend, like that. And then we here inside of here we'll have stuff like rotate. That will take an angle that it should rotate with. Call it theta for now. Have a scale method that will take a constant as a parameter. That just means how much we will scale the polygon in size. And then we have the pass point function. That was the one I showed before. So that will take an x and a y position as augment, or an ox, oy, I guess. Yeah. So offset, and then the test point, like that. But yeah, so that's basically it. And of course we also have a constructor that will just take an array of points as argument, and then inside here we say this dot points equals p dot slice 0. Slice in this context means that we'll copy all the points there, and we'll need to do that later on when we are having a library of points, and we don't want them to be the same on every object, since when we rotate one of them, all will rotate. So that's why we copy them for each individual polygon. Anyway, so let's do update the canvas now. So I have the draw polygon method. So it's called draw polygon, and that's equal to our function, of course, like that. And it will take a polygon as a parameter, then an x and a y position where to draw that polygon. We say p equals p dot points, like that. And then we can say this, in this case, will point towards the context object. So we can say this dot begin path, this dot stroke, like that. And then we say this dot move to p0, so the first x position plus x, and then the first y position plus y, so we move to that point. Then we loop draw the rest of the polygons, or the rest of the vertices. Say var I equals 2, len equals p dot length, I is less than len, I plus equals 2 here. So the step size of 2 is very important here. Now we say this dot line to pi plus x, pi plus 1 plus y, yes. So that's basic draw polygon function there for you guys. So let's see if this actually works. So let's go to the game state. Let's create our render call here, our render method that took the context as a parameter, and let's just create a real simple polygon. So we say new polygon, like that. That took a list of vertices. So we can say, let's say, yeah, let's take -1, -1, yep, 1, 1, yep, and then -1, 1, -1, and -1, like that. Now we can say this dot poly dot scale, so it should be a bit bigger, and let's scale it by 10, I guess. And let's just implement that method real quick. So that's real simple. We say var I, for var I equals 0, len equals list of points, length, I is less than len, I plus plus. So this time we won't have 2 as a step size, but 1. And then we'll say this the points I times equals c, like that. And that should scale the polygon to the size we want. So yeah, so I think we're good to go. Let's make sure that we call context draw polygon, this dot poly, and at a particular shape. So let's draw it at 100, 100. And let's just set the stroke style so we actually can see the polygon. So we say this canvas a constant of stroke style, and let's set it to white for now. And hopefully now we should see some sort of polygon drawn. Well, it didn't work, so let's see. Unexpected identifier. Okay, I forgot a comma sign here, and now hopefully now got another error. Extend, should be extend. Yeah, so now we can see that the polygon is drawn here to the canvas. And let's scale it a bit more. So let's scale it to 50. It should be 5 times the big size, and yeah, here you can see the polygon drawn. But it is drawn over and over again. hence the thick line. So let's add another method to the canvas context. So we can say context.clear all equals function. We won't take any parameters, but we'll say this.clear rect 0, 0, this is width, this is the height, like that. Then we basically, before we draw the polygon, we say context.clear all. Yeah, and now we have the polygon drawn the right way here. So anyway, let's do the rotation function now of the polygon. So that's really simple. We just cache the cosinus and sinus values of the rotation angle. So we say map.cosinus theta, like that. And for the sinus, say map.sinus theta, like that. And then we loop through all the points with the step size of 2 again. So we say len equals this dot points dot length, I is less than len, I plus equals 2. And then we can say bar x equals this dot points at I, and the y value is this dot points I plus 1, of course. And then we set the point values again. So we say this points dot I equals cosinus times x minus sinus times y, like that. And then for y, the new y value, we say sinus times x plus cosinus times y. So that's the rotation function, real simple. So let's see if it works. So let's go to the game state, let's go to the update method, and you can say this poly dot rotate 0.01, I guess. And now you can see that the polygon is actually rotating. So this is working real good. So far, so good. But just to have a polygon is a bit boring, so let's actually draw some asteroids, since it is asteroid games we are making. That should probably be the last thing to do here before we end this episode in this particular tutorial series. Anyway, let's create a new file again, call it asteroid.js, like that. Create asteroid class, so asteroid, and that will actually extend the polygon class if we want, so yeah, why not? So we say this polygon.extend, spelled right this time, and the constructor, it took a list of points, I think, as a parameter, and will also take an x and y position. But we basically call the super constructor with a list of points, like that. And then we basically set the x and the y positions here to x and y, like that, I guess. So that's it for the asteroid. But let's do a draw method as well. That can take a context, and then we say context.draw polygon. This and this are x, and this are y as parameters, like that. So let's see if it works so far. So I'll just include the asteroid file here. So asteroid.js. Yep. And for now, yes, let's just go to the game class again. We can close down some stuff we won't need. This we won't need. This we won't need. This we won't need, at least not for now. Yeah. Anyway. So instead of poly, let's create an aster, and that will be equal to a new asteroid, like that. And for the x and y position, let's set it to 100, 100 again. And inside of the asteroid class here, we can say this.scale s, and let's set the scale here as a second parameter. Anyway, so let's set the scale. Let's set it to 20 for now. This we can remove, and then we just say this.aster.draw to the context. Let's see what will happen. Yep, it is drawn at least. and we can increase the size here, I think. Yeah, so that's working, but the sprite is a bit boring, so let's actually create some more cool looking assets to the game. And for that I have this polygon draw program I have developed, and it wasn't mean that you should see this image now, but you can basically just add that image into the source code here if you want, down here in the after all of the basic GUI settings and stuff. Anyways, so if you go to that article here where this image is inside, you can read some of the history behind the Asteroid game. And that's really cool. You can read of the people that made the first game and how you can exploit some of the game mechanics in the original arcade game. Anyway, so I will leave the link down in the description. But we will basically just go create these shapes here. So you can create shapes by clicking on the grid system, and you can clear it using this button. You can't use the back and forward buttons, I haven't implemented them yet, and you can't use the move tool either, or the layer tools and anything, so yeah, anyways. But you can create this to change between different coordinates, and I highly recommend to use this kind of coordinates, and you can select them using this button, and then you can copy them, right click and then copy, or you can just Command C or Control C, anyways. And as I said, this will clear the canvas. So I can do the first asteroid here for you, and then I will do the rest of them off camera, or in a time lapse or something like that. So the first, it looks to be like 4 squares and 2 up, so you can look here on what coordinate you're at, so 4 minus 4, 4 minus 2, yeah, that seems too good. And then it goes something like that, it looks like, yep, or like so, like so, like so, like so, like so. So that's the first asteroid there for you guys. Now you can select it, copy it, and let's set, yeah, can go up here, I guess. Create a points list, like so, and we call the asteroids, like that, to a new list with all the points here. So we have the first asteroid here, and then we can say points asteroids 0 for now, and that should give us a bit more interesting shape. Yeah, so here we can see that now is that particular asteroid drawn. So I'll do the rest of them here in the time lapse, and I will see you when I'm back. So be right back. Yeah, so that was all of the asteroids. So let's just make so that we create a random asteroid. So to do that, we can calculate the n here, and then we can say math of round, math of cosinus, math of random times points, asteroids, length, minus 1, like that. And then we just set the n here into the asteroids, and each time now we reload the page, we should get the new type of asteroid. So that seems to be working, so that's good. So let's make the move, and then let's call it a day. So to do that, we can create the update method on the asteroid object, or the asteroid class. And let's create a velocity as well. Let's say this dot velocity. Before we do that though, let's get a random angle. So we say well, r equals 2 times math of pi. So this is in radians, so a value between 0 and 360 degrees. And let's get it a random speed as well. So we say bar b equals yeah, math or random times 4 plus 1, I guess that's good speed, at least in the testing phase. Now we say x equals to b times math of cosinus, or y equals v times math dot sinus, or like that. Then we can say this of x plus equals x, this of y plus equals, this of velocity y, this of velocity of x, like that. And let's rotate it as well. So we'll rotate this dot r, or root angle, yeah, let's call it like that, root angle. And let's set that also here at the top, so we say this dot root angle equals 0.01, I guess, times math or random times 2 minus 1, like that. So that should give us a random value between 0.01 and minus 0.01. Anyway, so that's the basic asteroid here. So let's go down to the game state and let's just check if it works. So we say this is asteroid update. And now you can see that it moves in random angles like that. So that's good. But it's moving out of the canvas and we want it to loop over and over. So let's just fix that as well. So to do that, we can do it like this. So we can set max x, set it to null at start, and the max y, can set that to null as well. And then in the game state, we can basically say, after we have created the asteroid, we can say this dot aster equals, dot max x equals game dot canvas dot context or width, or canvas or width. That's, no, we need to say context of width, sorry. And this dot aster dot max y equals game dot canvas dot context dot height, like that. Then in the updates, all we need to do is to check if what do you say? If yeah, you can say if this dot x is bigger than the max value, so this dot max x, then we say this x equals 0, and then we can say else if this dot x is smaller than 0, then we say this dot x equals this dot max x, like that. Then of course we should just change this to y, so we should do that for both the x and the y directions, like so, I guess. Just this one as well. And let's add yeah, semicolons to the edge, to the end there. And hopefully now, when we reload the page, the canvas should be looping over the course of the canvas. So that seems to be the case here. So let's add a bunch of asteroids and let's see, check if they work as they should here. So we can just tab that in one step, or actually we can do it for all of them. And then we can say this to asteroids equals to a new array, our empty list, and then we say for var I equals 0, I is less than, let's say, 10 for now, I++, like that. Just create some new asteroids, and we can say var here instead, I guess, like that. And then we just push it to the asteroid array, so we say this asteroids push asteroid, like that. And then instead of this asteroid update and this asteroid draw, so you can do it like this, I guess. Yep. So you can just say for var I equals 0, len equals this long asteroids or length. I is less than the len, I plus plus, and say this asteroids at I dot update. And here we change to draw, of course, with the context as parameter. And now we can see we have a bunch of asteroids drawn to the canvas. So that's it for today, guys. And I hope you enjoyed this video. And I will continue this series real soon. So thank you for watching, guys. And I hope I see you in the next video. Bye.